Hi students, welcome to the coding class. Today's topic is swapping of two integers. Now let us directly focus on the swapping logic what we want to discuss today. First is we will swap two integers with the help of a third variable. So with the help of a third variable. Fine. So let us see. So as we know, we are aware of the structure of this language, what C supports. There is a main function. The return type is void, as we know. The main focus, what we want to do is the swapping of two numbers, two integers basically. So fine. So let us take two integers, a equals to 5 and b equals to 6. And another temporary variable, we are giving the relevant name temp. So initial, this is the step. So once we are declaring this, we would like to see the values. So what do we understand? Definitely A will have 5, B will have 6. And though we have not printed the temporary variable, but if we want to see the value of temp, then we will give a print and we will be able to see the value of temporary variable temp. When nothing is, no value is initialized, it is basically 0 in this compiler environment. Okay, right. So here we expect that temp will be 0, right. Now let us go for these three major steps for swapping the two values. As we understand, swapping means interchange. That means initially A was having 5, B was having value 6. But after swapping, what we expect? A will have the value 6 and B will have the value 5. So for doing that, we are coming to this three steps. So in this line, that means line number 10. What does it mean? It means that temp which was having the value 0, it will have the value of A. These are simple assignment operator. So A was having what? 5. So temp will have 5 value. Coming to the next line. This line says that A will be assigned with the value of B. So A will have the value B. What is B? B is 6. So at this stage, A should have the value 6. Next, line number 12. Here we say that B is having the value of 10. That means B is assigned with the value of temp. So B will have the value of temp. Now what is the value of temp, students? 5. So it will have 5. And after that, finally, the swapping statements, three statements, after its execution, we will check the value of swap value of A and B. And definitely, we understand that A will have what? 6. Yes. And B will have 5. So you see, initially line number 7, which was before swap, it was A was 5 and B was 6. But here, after swap, A is 6 and B is 5. So this should be the expected result. So now let us check it. Can you see it clearly? See, before swap, A is 5 and B is 6. And temporary variable, if you recall, this temp was when? It was just before any swapping taken place. That means temp when it was nothing was initialized. So default value was 0. So that 0 is printed over here. Okay, just a sec. Fine. So let it come, the answer. Okay. So before swap A5 and B6 and after swap A6 and B5. So our aim is fulfilled. Okay. So this logic is about the swapping of two integers with the help of a third variable. Now, third variable is having a extra space. If we can change our way of doing this swapping without a third variable, definitely it would be a memory efficient way. So let us check this. Now, for now, please don't put any attention on these two lines. I'll be coming to you. Let us check this logic. Again, A is 5 initially and B is 6, as before we have done. But here you see there is no temporary variable, because what is our uh, aim here? Our aim is to swap two integers without a third variable. Fine. Variable. Okay. So we are not taking any temporary variable here. Again, I'm repeating, please don't give any emphasis on these two lines for now. I'll come back. So here what is the scenario? In line number 9, see, before swap A should be what? Same, nothing is done, so A should be 5 and B should be 6. Agree na? Okay. Now we are swapping the two integers values using arithmetic operation. Here we have used arithmetic operation, multiplication and division. So let us follow these three lines. Again, these three lines are giving the are helping in the task to do the swapping. Okay. So what does it mean? Now A will have the product of A into B. So what is A? 5. So 5 cross 6. What does it mean? 30. Fine. Next line. B will be assigned by the value of A by B. Now what is A? A is 30. So 30 divided by B. What is B? Initially it is 6. So here also there is no change. So it will be 6. And then what will be the value? It will be 5. Okay. Now let us come to the line number 14. Here A is assigned with the value after the operation of A by B. So now what is A, students? It is 30. And what is the value of B now? It is 5. Okay. So what does it do? It will be 6. So just after these three lines, after applying this arithmetic operators, multiplication and division, A will have the value 6, whereas B will have the value 5. Now again, all of you please check this line number 9 and line number 15. Initially it was 5a was 5 and b was 6, but after the swapping a has become 6 and b has become 5. So is the task done? Yes, it is done. Okay, now let us check with these two numbers. We have checked with 5 and 6. Now we are checking with these two huge numbers. Now if we take these numbers, let us check. Okay, 5 and 6 we haven't run. Let us execute it and show you. So this output is coming. A was 5 and B was 6. But after swap, A is 6 and B is 5. So our objective is okay, fulfilled. Now let us take with the I'll take a different data. Not 5 and 6 anymore. Rather, I'll take this huge data. These two big numbers. Okay. Now see what happens. So A and B here will have these big numbers, these two numbers, right? Now after this swap, definitely these things will not happen. These values are not applicable anymore. So again multiplication of A and B will happen, and then the division will be taking place. I am not going through the arithmetic calculation. The calculation will take place. It is a it is understandable that the arithmetic operations will take place, but what will be the output? So your expectation is A will have this value, B's value, and B will have A's value. Swapping. So let's check with the output whether it is happening or not. Please look. Before swap, as it was, we have given the numbers like this. It is okay. But after swap, see, the values are not okay. Some way B is having -1. So that means what we have given as input, it is not coming. Now why it is not coming? What is the reason? The reason is there is one concept, that is the data range. See, here we are using integer data type. So every data type will have some range, minimum range to maximum range. And this range will vary from system architecture and the compiler we are using. So as we are using dev C++, let us check that in dev C++ what is the limit of this range. So here we are using this int min and int max, these macros, so to understand what is the minimum and maximum limit of the integer. Please note it very carefully. The minimum integer supported by this int, which takes 32 bits, 4 byte, the size of integer here is 32 bits. With the 32 bits, maximum means lowest negative number is this one, -2147483648, and the maximum positive number is +2147483647. So this is a huge range. Now, okay, fine. You have checked the range. Now let us come to the problem again, where we were discussing. So with the third variable, this was the case. So in this case, what is happening when we are multiplying these two numbers here? We are multiplying A multiplied by B. So all of us definitely understand after multiplying, the product will never lie within the range. It will be wrapped around and some other values will be basically represented. It will be considered. Some other values, not that value will be considered. So Basically, this range issue is exceeding the limit of 32-bit signed integer, and it wraps around, and some other values are calculated in means other than that, means 21474. If I take these two numbers and multiply, a huge number is coming which is not lying within the range, so it is wrapping around and some other values are assigned basically. So when some other values are assigned, so what we try to interchange, what values we want to see, that value will never be represented correctly. That is why we are not getting the correct result here. So this is a problem in this case. So whenever, that means we have to be very careful about these range issues. We call it the integer overflow problem. So this integer overflow problem we can overcome. So now let us come to the third way of the solution for swapping two numbers. Again, here we will not take the third variable. Still, we will do the task, and here we will overcome this integer overflow condition and successfully we will do the task. So now let us come to the third operation. Okay. So here again we are taking the same two big values. Now you see. Now what we are doing? We are not using any arithmetic operation. We are using here bitwise XOR. So let us just quickly recall what is bitwise XOR. Okay. So let us take the XOR. If we take two bits A and B and perform A XOR B, this is the operator supported in C language. Now the two bits 0 0, 0 1, 1 0 and 1 1. As we all know, when there are different inputs, the answer is 1 in case of XOR, and when there are same inputs, the answer is 0 in XOR. So this truth table, all of us we have already come across earlier. So now let us take this example. See, though we have taken this example with these two huge numbers, but making the binaries of these two huge numbers and working here, it's a quite bit tough task. So for understanding the logic, we are taking the small numbers 5 and 6. Here, the operation will take place bitwise. Okay. So we are taking 5 and 6. So whenever 5 is taken, what will happen? 5 is a decimal number, as we know. But when the bitwise operation is concerned, it will be considered, it will work on binary version of the decimal. So what is the binary version of 5? It is binary equivalent of 5, it is 101. Similarly, what is the binary equivalent of 6? It is 110. Fine. Now, can we do it? This thing 3. Let us do 1 second. Can we do this? Oh, okay. Let us check. This is the first, these 3 lines. A is having the value stored in it after the XOR operation with initial A and B. Okay. So let us minimize this. Now let us do the XOR operation. So A will have the value stored after applying A XOR B. So let us do that. 1 0 1 1 0 1 0 0 1 1 is 0. So A is having this value. Next was what? Again A XOR B. Now this is our new A and this is our B for now. So again, when we will do this XOR operation, 110, we will do the XOR operation. Sorry, 110. This portion. And we are keeping in B. So let us do the XOR. 10, 1, 110, 101. So where it is kept? It is kept in B. Look, what is the decimal equivalent of this 101? It is 5. The last line, if you check the third line, basically, second one we have done. Now we are doing this one. A XOR B again. And but this time we are keeping in A. Fine. So A will have A XOR B. Now what is the latest A? Latest A is this. Let us put it here. And B is this. We have got it. Now again XOR. So 110, 101, 101. This is stored in A. So basically what is the decimal equivalent? It is 6. So please note A was 5 but now A is 6. B was 6 but now B is 5. So is the task done? And as you can see, the operation is done bit by bit. No overflow cases will be there. So here we have overcome the problem what we have faced during our arithmetic operation. Okay, so hope all these three approaches you have learned one by one and hope you have understood. So let us summarize within 1 or 2 minutes. First, what we have done, we have swapped the two numbers, two integers with a third variable. But when we are using a third variable, we are using one extra variable. So we will go for a better way of solving it. We are taking off the third variable, and without the third variable we want to do. So when we are doing that, we are using the arithmetic operation. As you can see, again another one I did not say, we can do like this also. A equals to A plus B, B equals to A minus B. This is for your homework. You will just check. Again, A is equals to A minus B. Both the operators will work. Okay, but again, it will work, but it will face this kind of overflow condition, integer overflow, if two huge numbers are taken into consideration. So it is better approach than the previous, but again it is having some shortfalls. So how to remove that? By taking the another operation, bitwise operation, that is XOR. And I have explained here what is the XOR operation about. You can take a screenshot, you can practice on your own. Hope the class will be effective. Please practice it, and tomorrow we will again meet. Okay, so for now it is done. Thanks all.